Uh-oh, we got ourselves a lag. If I talk about sampling distribution of means, all right? So remember, again, this is arbitrarily chosen. Let's just let n equal 5. If I were to take the sampling distribution of the means of the gifted kids, of the number of kids number of siblings that they had, believe it or not, what I would get is the distribution would look normal. Always. All right? Now, the coolest thing is that not only would the distribution of this, would the sampling distribution of means be normal, but this mean right here, all right, would be exactly the mean of the population. In other words, there is a mean number of siblings that gifted kids have. And this sampling distribution of means would head for this number. All right? Now, what do you mean, Ripley? What do you mean head for that number? Remember the law of large numbers? Clearly, if I'm finding all possible samples of size n equals 5 from the population of gifted kids, there's a whole lot of gifted kids out there. All right? I would be able to figure out what the mean of the population is. Now, that is powerful good stuff. That's incredible stuff. Now, let's talk about the sampling distribution. This is one of the really cool ones as well, of the proportions. Proportions. Guess what? The shape of the distribution, if I took all of those distributions, or excuse me, all of those proportions, excuse me, and I drew out their distribution, it would also be normal. And the mean of this distribution, this guy living right in the middle, would be the true population proportion. So from the samples, proportion, from the samples, I can get to the population proposal, through population proportion. All right? Now, remember, I've got all these p hats flopping around here. I got p hats, and they're going to have certain values, whatever they are. That's going to be p hat 2, and there's going to be p hat 5 sitting up here, and maybe p hat 19,075 laying over here. Those proportions are going to be all over the place. Because remember, I'm just grabbing all these samples and saying, all right, what proportion of you, what proportion of you have siblings? Just like up here, I've got all these X bars. I got X bar 1 over here, and X bar 2 over here, X bar 3 over here, maybe X bar 17,019 over here. These are the means of each one of the sampling distributions, and they're going to be all over the place. But they're going to gather around the actual population mean. Sampling distribution of the means, sampling distributions of the proportions are incredible, and they're incredibly useful because look at what happens. They suck down to the mean of the population, which is incredibly useful. Now, let's talk, last but not least, sampling distribution of the variances. Now, this one's actually pretty cool. However, it's more of an advanced topic. Remember, variances are always positive because they're squared. And what we end up with is this crazy looking curve that's actually called an F curve. It's got this, it's got this tail to it. It's got this right tail. It's got to be right-tailed because variances always have positive numbers. That's terrible. Let me try and redraw that right there. All right, this is not a normal curve. This is a right skew. All right? Right skew. Now, this is pretty cool. Again, remember, we found S1 over here, and maybe this was S2 over here, and S15 over here, and F Google. I guess there probably wouldn't be a Google, but there's going to be a whole boatload of them. The average, remember, the average is going to be a little bit to the right of the mode because it's getting sucked over here by the tail. The mean of this distribution, All right, I don't want to confuse, even though I'm throwing a whole lot of statistics terms at you. The mean of this distribution is actually the variance of the population. That is so cool. Now, notice what's happening. The sampling distributions always target in on the parameter. The sampling distribution of the statistic targets the parameter. The sampling distributions of the means has a mean that is equal to the population mean, or mu. The sampling distribution of the proportions, of the sample proportions, targets in on the true population proportion, which we call P. The sampling distribution of the variance has an average. Remember, it's still a distribution. The average, if I'm looking at, this one is where it gets a little crazy because my terminology gets nuts. If, let's say that this is the mean value of this distribution, which is a distribution of variances, the mean value of this is equal to the parameter, the variance, which implies that we can get to the standard deviation. If I have the parameter variance, then I have the parameter standard deviation. Super powerful. All right? Now, there is a term called an unbiased estimator. Unbiased estimator. Now, estimator. If you think of bias not as being like, oh, I can't stand, I don't know, dogs, or I'm biased against cats, or whatever. In the statistical context, unbiased means that you don't have a tendency to favor some specific outcome. All right? In other words, if the mean of the population is mu, the sampling distribution of means gets sucked to that mean, not some other value. And that is referred to as an unbiased estimator. In other words, sampling distributions of means, proportions, and variances are unbiased estimators. They head to the parameter. All right? So what we're saying is that sampling discs, that is, I don't know what just happened there. Maybe too much caffeine for lunch. You never can tell. I know that sampling distributions, sampling discs, head for the parameter, which implies they are unbiased estimators. That's really just a term, okay, that's going to pop up in your statistical adventures. All right? Now, we're going to have some serious fun with this fact, the fact that sample means, sample proportions, sample distribution of means. You'll hear me sometimes shorten that up to sample means, sample proportions, and sample variances. Head for these values. It gives us such an amazing tool. It's unreal. If you could see me right now, you'd see my hands flopping around like a crazy man at an auction. All right? It's so cool. Well, that's enough of the vocab. Now let's get into some real fun. Boo!